So then, if I want to find the area between two polar curves, the idea of it is basically that I want to take the area of the outer, so my outer area, and subtract the inner area. Ah, sometimes you will see in a textbook that this has been combined into a single integral, but that assumes the bounds are the same. And to be quite honest with you, it's actually kind of common that the bounds are not the same. So we have no guarantee, like now, because if we're dealing in rectangular, I do top minus bottom, and the bounds will always be the same for the top and the bottom. But because polar is concerned not just with the final shape we get, but the order that we draw it in, where we start, where we end, my bounds don't necessarily have to match. So I really do strongly recommend that you keep these areas separated and think of, I need to find my outer area, and then I'm going to take away my inner area. And then once you set it up, if your bounds match and you choose to use the property of integrals, the sum and difference property of integrals, you're welcome to do so. But here, we want to find the area that lies inside the circle, r equals 1, and outside the cardioid, r equals 1 minus cosine theta. So the area that we're being asked to find is this area here. And notice I always will be filling these in to help reinforce in my mind the idea of, okay, it's always being measured from the radius. So I need to figure out what's my outer, what's my inner. Well, looking at this, the circle is the outer. So my circle is outer, and that means my cardioid is inner. And so I'm going to start with my circle. And for my circle, if theta is 0, I'm starting here. Pi over 2, pi, 3 pi over 2, back to 2 pi. Now, the issue here is that looking at how I sketched it, it looks like I'm going from 3 pi over 2 to pi over 2, but I can't do that because that would actually be going backwards. A couple ways to get around it. If you're comfortable dealing with negative angles, the 3 pi over 2 is the same as negative pi over 2. I'll admit I'm not super big on that. The other thing you can do is take advantage of symmetry. And I notice that if I cut this here and find from 0 to pi over 2, that's going to be exactly the same as going from 3 pi over 2 to 0. So for my outer, I'm going to say that I'm going from 0 to pi over 2 of 1/2. My radius is 1 squared with respect to theta. But then I need to double that because that's only half of my area. I want the other half. Then for my inner, okay, so if theta is 0, I get 1 minus 1, which is 0. Pi over 2 gives me 1 minus 0, which is 1. So then this is pi, 3 pi over 2, and back to 2 pi. So this one actually does work out nicely in that I do end up getting the same bounds. Again, I can't say going from 3 pi over 2 to pi over 2 because that actually would be over in this area, and I don't want that part. So I'm going to take advantage of my symmetry, just like I did with the circle, and say that I'm going to be doing the integral from 0 to pi over 2 to find half of the area. So then 1/2 times my radius squared. But I need to double that because to get my entire area, and then I subtract that from my outer. And when I evaluate this, I get 1.215 for my entire area inside the circle, but outside the cardioid.